Welcome to Gumber's Mathematics classes. Hope you liked the video. Subscribe our channel and press the bell icon to never miss another updates.
Hello everyone. Today's topic is distance formula in coordinate geometry. Let us consider we have to find the distance between two points, that is A and B. How we can find this distance? Now, if we are not considering Cartesian plane coordinate geometry, we can see that this is a right angled triangle, right angled at, let us name it as point L, right angled at point L. So, if we observe that this is a right angled triangle and we have a formula to find the hypotenuse, here AB is acting as hypotenuse. So, we can find hypotenuse with the formula that hypotenuse square is equal to perpendicular square plus base square. Now in this case, what is the length of perpendicular? Perpendicular is 15. Therefore, perpendicular square means 15 square plus base square means 36 square. We will be writing here 36 square, and this is equal to 225 plus 1296. Yes, and this is equal to the sum of these two numbers is 1521, and the under root of this, to find the value of h, we can find it as, we can write it as, this is h square is equal to 1521 and h is equal to under the root of 1521, and this is equal to 39. This is the square of 39. Hence the hypotenuse is 39. Therefore, the length of the side AB is 39 units. 39 units. This is the way to find the distance between two points. And let's try to solve few more queries. Let we have to find the distance AB from the given figure. This distance AB we need to find. How we can find the distance between these two? For this, very first we need to find the distance, or you can say that this is at 4 meters, 4 units apart from one point, that is O, and this point B is 6 meters, 6 units apart from same point O. How to find the distance between two points A and B? Yes, absolutely correct. AB is equal to OB minus OA. The distance between AB is equal to OB, very first complete distance, the distance of point B from the origin, and then minus OA, the distance from the same point O to A. You will be getting the distance, this distance, and this here it is equal to OB. This OB is equal to 6 units and OA is equal to 4 units. So 6 minus 4, that is equal to 2 units is the distance between point A and B. Similarly, CD is the point on y-axis. We can find the distance between these 2 points with the help of OD minus OC. OD minus OC, and the distance of point O from origin is, from the reference point, is 8 units. Absolutely correct. This is 8 minus OC. OC is the distance from origin to point C. So this is the distance is equal to 3. Therefore, the unit is 5. The distance is 5 units. Now, next is, let me erase this in between this line. Now, the distance is, now we are supposed to find the distance AC. How we can find the distance AC? This distance AC. AC in figure, this is here AC. How to find this? Now we can clearly observe that this is again right angled triangle, and we can find the distance with the help of Pythagoras theorem. Let's see how we can. This is O, this was O, AC we are supposed to find. Let's see how we can find AC. So disturbance with technical problems, some issues are there. So let's work on that. Now AC we are supposed to find with the help of Pythagoras theorem. Next, AC is equal to OA square. AC square is equal to OA square plus OC square in right angle triangle AOC. This triangle. This angle is 90 degree and we are supposed to find hypotenuse. This way we can calculate, and OA is equal to 4 units. This is 4 square, and OC is equal to 3 units. This is equal to 3 units. And one more thing, we can use here Pythagoras triplets also. Base and perpendicular are given to us as 3 and 4. We can directly write as AC is equal to 5, or otherwise you can use the formula for Pythagoras theorem. That is 4 square is 16 plus 3 square is 9, which sum gives us 25 under the root, and this is equal to 5 only. Therefore, the value of AC, the distance between AC is equal to 5 units. This is the way to find the distance between 2 points. Now BD, we have to find the distance BD. This distance, if we need to find, how to find that distance? Let's see how we can find this distance. Absolutely correct, with the help of Pythagoras theorem. And here also we'll be getting, let's rewrite it. Let me erase this very first, make the screen clear. Now we are supposed to find BD square. This we are supposed to find. Technical issue is there. I don't know why is it so happening. Okay. Come. Yes. Now BD square is equal to, similarly with the help of Pythagoras theorem, we can say that this is equal to OB square plus OD square. Perpendicular square, base square, their sum, and it gives the square of hypotenuse. Now OB square is equal to 6 square, and OD is equal to 8 units, 8 square, and this is equal to 36 plus 64, which is equal to 100. BD square is equal to 100, therefore BD is equal to under the root of 100, that is equal to 10 units. Or directly with the help of Pythagoras triplets also you can write this is the 100 units. Now let's consider one more question. If we have to point, it was in previous example, if we see, our distances were related to origin. We found OA, that was also related to origin, OA, O to A, then OB also, and AB also with the help of OA and OB. And here also AC we have found with the help of this 90 degree at origin. Now the point is, if the points are somewhere else in any of the other quadrant, first quadrant, third quadrant, any of the quadrant, how we can? Now the question is how to find the distance between these two given points, and the points are P and Q. The coordinates of point P are given to us 4, 6, and the coordinates of point Q are given to us as 6, 8. How to find these distances PQ? Let's see how to find. Very first, for finding PQ, we must be knowing. No doubt we'll be finding it with the help of Pythagoras, but see how. Very first, we'll be joining this P with, we will be drawing a perpendicular PR on x-axis and QS perpendicular on x-axis. Now we will be joining this in such a way that this is also perpendicular, or we can say that this is perpendicular to this. So we will be getting this kind of structure with this kind of triangle where P, T and Q is a triangle right angled at P. Now we are supposed to find the length of PQ, or distance between point P and Q. Let's see how we can. For this we want the length of QT and we want the length of PT. Let's see how we can find these lengths. For this we will be taking help of RS. How we can find RS? Similarly, previously we have done RS is equal to OS minus OR. So how we can find? OS is equal to 6 units. OS is 6 units. And OR is equal to 4 units. Now RS is equal to OS minus OR, which is equal to 6 units minus 4 units, which is equal to 2 units. Now next is PT. PT is this distance. PT is equal to RS. Absolutely correct. Same distance we can take here. Because it's a rectangle also we can consider 90-degree lines are parallel. This is also parallel to this. It's a parallelogram with 90 degree. Therefore it is a rectangle. Now PT is also equal to 2 units. Now is the point of QS. How we can find QS, Q2S? Basically we are supposed to find QT. Let's see how we can find QT. For this we want, for finding QT, very first we will be finding, to find QT, very first we will be finding QS, subtracting this TS from QS. So let's see how we'll get. Now what's the list? Think about this. QS is equal to distance of point Q from x-axis, that is ordinate, and this is equal to 8 units. Now TS is the distance of point T from x-axis, that is ordinate. Ordinate of this point is point T is, this is having 6 distance from y-axis and distance 6 also from x-axis. The point coordinates of point T are 6 is to 6, 6, 6, and TS distance TS is equal to, this TS is equal to 6 units. Now QT is equal to 8 minus 6, that is equal to 2 units. Now we are supposed to find QP. Clearly we can find QP. QP with the help of Pythagoras theorem, we can write that QP square is equal to PT square plus QT square. We are considering right angle triangle PQT, and this is equal to PT. PT is equal to 2 units plus QT. QT is equal to 2 units. Here also 2 square. This is equal to 4 plus 4, which is equal to 8. QP is equal to under the root 8, which is equal to 2 root 2 units. This is the distance between point P and Q, that is 2 root 2 units. This is the way we can find the distance between 2 points. Now let's derive the formula for that with the help of variables. That is, let us consider if P is x1, y1 and the coordinates of point Q are x2, y2. How to find the distance between P and Q? Similarly, as we have done in previous case, we will be doing same work with the help of these variables x1, y1, x2 and y2. In previous question, we tried to find this distance, then we applied Pythagoras theorem for this. So let's see. Very first, PT is equal to RS. RS is equal to OS minus RS. Now OS means what are the coordinates of point S? What is the distance of point T? What is the point Q? Distance from y-axis. This is x2, 0, that is abscissa of the point Q. Now the coordinates of point R are, its y coordinate is 0 and its x coordinate is same as P is having, and the abscissa of this point is x1. Therefore the coordinates of point R are x1, 0. Now the coordinates of point T are, now the points T coordinates of point T are, what are the coordinates for this point? This is this units away from y-axis, this units away from x-axis. So y-axis it is away from x2, and the height of this point we can say, and this is according to y1. The coordinates of point T are x2, y1. Now let's find few of the distances. PT is equal to RS, and this RS is equal to x2 minus x1. From the figure on the x-axis we can find this. Next is, second is, we want qt. Qt is equal to, as the coordinates are present over here, we can write it as y2 minus y1. Now apply Pythagoras theorem to find the distance between point P and Q. Therefore, in right angled triangle, PTQ, we have PQ square is equal to QT square plus PT square, and this is equal to QT is equal to y2 minus y1 whole square plus PT is equal to x2 minus x1. Here we have written wrong, this is 1. You can recheck also that this PT is equal to RS and RS is equal to x2 minus x1. That is to be 1. Now we are supposed to find PQ distance or QP. This is equal to under the root of y2 minus y1 whole square plus x2 minus x1 whole square, and this can be rewritten as we are habitual in writing x terms first, so we can write it as x2 minus x1 square plus y2 minus y1 whole square. Why we can write this? Because addition is commutative, we can exchange their orders. So this way also, and second thing, you can write it as this also. Now I am changing the places of 1 and 2, x1 minus x2 whole square plus y1 minus y2 whole square. Is it right? Yes, it is right. Why it is right? Oh, it's not right. Why not right? Because it's not commutative. x1 minus x2 is not equal to x2 minus x1. So how we can write this? Yes, we can write this. How we can write this? Because here we are having square. Square means there are positive values we are talking about. Therefore, it will be equal. So we have nothing changed. It means it can be used in any of the way would you like to. So this is the final distance formula, that under the root x1 minus x2 whole square plus y1 minus y2 whole square, or you can remember it as the difference between x coordinates and the difference between y coordinates. We have to consider, square them, add them, under the root, we will be getting the distance of these. Finally, distance formula is the equal to under the root of x2 minus x1 whole square plus y2 minus y1 whole square. Thank you. Bye-bye.